Okay, grade sixes, as we begin this week, I just wanted to review the questions that you guys submitted last week. You guys did really great. I'm looking at page 126, number 5 to 10. So I'm going to start at number 7 because we didn't have any problems until then. So if you're tracking along, we're on page 126. So the question for number 7 says a basketball team won 2 out of every 3 games they played. So in my table, I'm going to label it games won and games played. So when it tells me that the team won 2 games, it tells me that I've played 3 games. Okay? Now, it also then tells me that the team played a total of 15 games. So I'm looking at games played, and the total is 15. The question asks me then, how many games did the team win? Well, for 15 games played then, I want to know the corresponding games won. So I need to know, how did I get from 3 to 15? And then I need to do the same thing to the 2 to get my proper ratio. So again, it's what did we multiply or divide by? So I multiplied by 5 to get from 3 to 15. So then I also need to do that on this side. When I multiply 2 by 5, I get 10. So to answer the question, how many games did the team win? It's 10. Okay, so for number 8, it says, what is the ratio of boys to girls in the class? Or the ratio of boys to girls in the class is 4 to 5. So if there's 20 boys, how many girls? What's really important, the order in which they say the ratio is the same as the order in which they say the numbers. So if we're saying the ratio of boys to girls is 4 to 5. We have to keep 4 with boys and 5 with girls. Now the question then also tells me there are 20 boys. How many girls will there be? I want to know that ratio. So again, I ask myself, what did I multiply 4 by to get to 20? And that's 5. So I also need to do the same thing to 5. So 5 times 5 is 25. So that tells me if there's 20 boys in the class, then there are 25 girls according to that ratio. All right, for number 9, we're looking at a map, and it tells me that for every centimeters on a map, 2 centimeters represents 5 kilometers. If a lake is 6 centimeters long on the map, how big is it in real life? How many kilometers is it? So 2 times 3 gives me 6. So 5 times 3 gives me 15. So the real length of the lake is 15 kilometers. Okay, and the last one here was a little bit tricky, just in the way that it was worded. In a pet shop, there are 3 cats for every 2 dogs. So I'm going to write my titles, cats and dogs, and I have 3 cats for every 2 dogs. Now, if there are 30 cats and dogs in the shop, how many dogs are there? Well, a few of you answered the question for if there are 30 cats, how many dogs are there? But it actually says if there are 30 cats and dogs. Well, I don't really have a column here for telling me the total of cats and dogs, so I might want to create that just off to the side. I'll write a total column. Well, if there's 3 cats and 2 dogs, I have a total of 5 animals. If I doubled that ratio or multiplied each of them by 2, I'd have 6 cats and 4 dogs for a total of 10. So what I'm looking for is, what is this dog amount when the total ends up being 30? So I'm just going to continue this ratio table for a little while and see when I get to a total of 30. So if I multiplied 3 by 3, I get 9, and 2 by 3, I get 6, 3 by 4, I get 12, 2 by 4, I get 8, and just so that I know I'm tracking along here, okay, now I'm at a total of 12 plus 8 is 20. That's still not enough. I want to know the number of dogs when I'm at a total of 30. So I'm going to keep going. 3 times 5 is 15. 2 times 5 is 10. 3 times 6 is 18. 2 times 6 is 12. If I check my total again, I have 18 plus 12. Well, now I'm at a total of 30. So I look at this ratio, because that's where it totals 30. And the question is asking me how many dogs are there. So the answer is 12. Okay, looking on the next page, we're going to continue on with looking at percentages. So I wrote in my description of your lesson that when we're looking at percentages, we're actually comparing a fraction that has a denominator of 100. So in order to change a fraction to a percent, we just need to make sure that the denominator is 100, and then we can easily change that number to a percent. For example, if I had 92 over 100, that's simply 92%. So as long as the fraction has a denominator of 100, the numerator becomes our percent. But sometimes it doesn't have a denominator of 100, and we have to do some calculations first. For example, if I had 4 over 50, 50 is not a denominator of 100, but I know pretty easily that if I multiplied 50 by 2, I'd get 100. So I'm going to create an equivalent fraction with a denominator of 100. So I multiplied the 50 by 2 to get to 100, and now I'm going to multiply the 4 by 2 to get to 8, and so I also know now that that will be 8%. Okay, so that's fairly straightforward. Now, the trick comes, if you're tracking along in your Jump Math book, the trick might come in questions like number 7, where the denominator is not easily made to 100 very easily. So I'll just do one of them with you as an example, and then you can do them later on your own. So let's say 10 over 40. Well, if I multiplied 40 by 2, I get to 80. And then 80 doesn't very easily go to 100 by multiplication or division. So I'm actually going to need to do 2 steps here. So I need to get 40 to 100. That's my goal. So if I divide both numbers by 10, I'm going to get, by 10, I'm going to get 1 over 4. Well, I now know that 4 times 25 will get me 100. So what I did here, just to review, I divided both by 10. And now what I'm going to do is multiply both by 25. So when I multiply both by 25, 4 times 25 is 100, and 1 times 25 is 25. So I get 25 over 100, which then I know is 25%. So it took 2 steps in order to get to 100. First I divided by 10 to get to a number that I could easily make to 100, and then I multiplied by 25 so that I could get the denominator to 100. Just a reminder, with equivalent fractions, they're just like ratios, in that when I do something to the numerator, as long as I do the same thing to the denominator, I haven't really changed the fraction at all. But I have to do the same thing to the numerator and to the denominator in order to keep it to be an equivalent fraction.